Okay, welcome, Jacqueline and Ross and Bailey and Justine. Thanks for showing up, and all those who are watching this as an archived webinar. Um, Today is actually the very last webinar of the whole quarter. It is kind of late June, so you can't be surprised that we're almost done. Let me tell you the plan of the day. What we're going to do is we're going to look at the ideas of Chapter 13. We're only doing pretty much one section of Chapter 13, so it's very short, but it's a very important section. You're going to think you understand it, but you don't. Just to let you know, it's actually a very deep topic. We're just going to learn basically how to write a hypothesis, put it in a calculator, and write down a conclusion. But there's a whole lot more to ANOVA, and that's what we're doing. ANOVA is it's used a lot, but anything more than what we're doing today is considered not elementary statistics. So if you're going to be getting a master's degree, you're going to be retaking the, you're going to take an advanced statistics class. Sometimes they call it applied statistics. And you're going to spend several weeks probably just on ANOVA. So just to let you know that we're just brushing through it. I'm only going to give you one example because I want to spend most of the time today talking about the final exam. I want to mention that I am about 2/3 of the way done reading through the projects. Some are very good, some are not as good, and good meaning that basically you have very clearly shown an understanding how to apply hypothesis test confidence intervals and the idea of the standard error. That's the main thing that I'm looking at. And some of you guys are right on, you get it. And then some of you I'm reading through and it's like, okay, you got a lot of work to do before the final. And you'll know who you are by looking at your grade and stuff. So that's the main plan of the day is I'm going to talk about the final exam. Just to note, the final exam is a week from Wednesday or earlier. I've already written it. I've actually sent it out to one proctor already. One that was, if you request it and you need it like right away, I can do that. My plan was tomorrow and Wednesday and Thursday. I'll send the rest of them out. By Wednesday, as in 2 days from today, if you haven't already, you must fill out the final exam information quiz. The way that works is if you don't fill it out by Wednesday, I take off 5% of your grade. And that's ugly. So in other words, you need to fill it out by Wednesday. Okay. Most of it's really easy. If it's the same situation as before, you write same, you give me the date you're taking it, and that's it. Very simple. If it's different, then you got to give me all the information for who to send it to and all that. If it's the same as a midterm, I already have the information from the midterm. So, and then what I'll do again tomorrow and Wednesday. Today, my big focus was getting these projects graded. I want to grade the projects so that you kind of knew what you're getting into for the final. They take a long time to grade, so I've been grading most of the day today, and definitely didn't finish. I'll be grading tomorrow, and then I'll try and also grade your Chapter 12 Week 10 discussion post. I figured that has less priority than your projects. But I will be looking at those tomorrow and possibly Wednesday if I don't finish tomorrow. That's my plan on the grading thing. So that's what's up. So if there are any questions, probably not about the final because that you should ask when we talk about the final. But if there's any other questions, this is a good time to ask. Any questions before I talk about the new material, Chapter 13? Which is one way ANOVA is what we're going to do, that part of it. Okay, so if there's no questions, let me remind you, because it's real important for the final also, what we've already done in terms of hypothesis testing. We know how to do a hypothesis test on a single population mean. If you remember, that was just a simple t-test. We know how to find a hypothesis test on a single population proportion. In your calculator, that was the one prop t-test. We know how to find a hypothesis test for comparing two population proportions. And in your calculator, that was a two prop 2 prop Z test. And then, if you remember, we moved on to 2 population means. And there were 2 types of those. There was paired data, and that was you find the differences and then use a t-test. And then there was independent data, and that was you don't find the differences, you plot it in L1 and L2 and do a 2-samp t-test. Then we moved on, if you remember, and we did chi-squared tests. We had a test to find out if a population has a different distribution than some known distribution. And that was the chi-squared test for goodness of fit. And then we went and we looked at finding out if 2 different populations had distributions different from each other. And that was a chi-squared test for homogeneity. And then we went and talked about whether 2 different qualitative survey answers had different answers from each other, were independent or dependent from each other, and that was the chi-squared test for independence. And then we looked at predicting one variable given another variable when they're both quantitative, and we did a hypothesis test on that, and that was the hypothesis test for correlation or for regression analysis. So here's what we haven't done yet, if you thought about it. There's a few things you haven't done, but this is the main thing we haven't done yet that's really important. And that is what happens when you want to compare many populations instead of just 2. So for example, if you want to find out, maybe it's true, maybe it's not, is there a difference in the population mean height based on the state you live in? You know, California might be different than Nevada, which could be the same as New York. Maybe that's different than Idaho, and etc. And hopefully you know that there's more than 2 states in the United States. Okay, so that's quantitative variable because it's how tall are you? And that has an answer. For example, I am 5'10", or about 70 inches. And you all have different heights, but the answer to the survey question will be quantitative. But I was born in California, or I live in California. Most of you live in California too, but other people live in other states. So we're talking about comparing many quantitative population means. And you want to find out, is there a difference, or is it dependent on state or not? Or maybe they're all the same. So when you're comparing more than 2 population means, we don't have a test to do that yet. Right? If you can think about it for a while, you'll realize that we have not covered anything that compares more than 2. We've only covered 2 and 1. And it turns out the test we're going to use is called the ANOVA test. Okay, what it stands for is actually very misleading, because what it means is analysis of variance, even though our test is for means. So I apologize, don't shoot the messenger. Everyone in the world calls it ANOVA, analysis of variance, but we're really analyzing whether the means are different. The deep math behind it is the reason why they call it analysis of variance. I'm not getting into that. Most of you do not want me to. If you do, then take advanced statistics in a math major. Just let you know it's pretty brutal. But what we can do is we can talk about comparing when we want to find out whether or not, sometimes we'll say, is the state you live in a factor in how tall you are? So I'm going to give you a different example, just for fun. So let me go ahead and share an example. It is that one. Okay, and let me make sure I can read the chat. There we go. Okay, so here's another example. A study was done to analyze the racial differences for the distance in miles that people live from the nearest public library. Okay, maybe it doesn't matter what race you are in terms of how far you are to the library, maybe it does. Okay, the data from the study are shown below. So I want to make note of something that's very important. This is horrible. You would never do this as a study. What's wrong with it? So see if you can put in the chat box or tell me what's wrong with it. Yeah. I mean, for example, the blacks, we got a sample size of 4. So do the others. Even white and Hispanic is a sample size of 6. So hopefully you know well enough at this point in class, you don't do sample sizes of 4. Okay, that doesn't do anything for you. There's a reason why I'm doing that today, and that is if we had the proper sample size, which is over 30, for example, even more if you want really good results, that would mean over 30 in each of the categories. We're talking about over, what, 124 at least. And I even pop this in the calculator, and you probably don't want to sit there watching me put over 130 numbers into the calculator. It would take all day long, and you'd be bored. Hopefully you agree with that. In the real world, though, you know, whatever you're doing is real important to you, and you do a study, and yeah, you got to pop in hundreds of data values into a calculator. You don't usually use calculators, you use computers. Okay, but again, I want to warn you, we're doing this not because this is realistic. We're doing it because I don't want to like torture you with typing in numbers. So a big disclaimer about this example. Okay, and if I give you one in the final, same thing's going to happen. There'll be a big disclaimer. It's got tiny sample sizes because you can't do it. In fact, if you wanted to find out the heights of people in the United States, depending on where they were born, well, there's 50 states, and we're talking about 50 times 100, and 50 times over 30, and that would be miserable typing it all in. Not to mention trying to get the data values. And that would be minimal sample size. So just a note, with ANOVA, you often have to spend a huge amount of time collecting data and getting into the computer. But we could do this. So here's we got the study. And what we want to do is we want to come up, and hopefully you all know this, with our null and alternative hypotheses. Okay, so everything we're doing is going to be hopefully what you're already familiar with, because we've been doing hypotheses for weeks now. What I like to start out with anyway, which is what you probably should do in every problem, is start out with the name of the test. Always a good idea, because if you don't know what test to use, you pretty much have no chance of succeeding. And this is called the ANOVA, A-N-O-V-A. And again, it stands for Analysis of Variance. I won't ask you for the full name, but you should know ANOVA. So it's called ANOVA. And when you have a hypothesis test, hopefully you all know that you write H naught, because that's how you always start a hypothesis test, right? All right, so if the null hypothesis is true, okay, what does that mean? So if we're in the status quo, reading what this says, what do you think that means? What do you think we're trying to decide about? Any thoughts? Yeah, same, not same. And in particular, about what is being the same, this is quantitative data. And when you have quantitative data, what that tells you is that we're talking about population means. And the symbol, and I need to use a brush because I don't have the ability to type in the symbol. The symbol is going to be mu, because that's population mean. And the first one is mu white, or mu, I'm going to write mu W. Now, H naught is always the equals, right? We're used to that. So in this case, mu W equals mu B. Equals mu H. Equals mu O. Any questions at all on writing out the null hypothesis for ANOVA? Okay, when you're doing ANOVA, it's all that mu of the first is mu of the second is mu equals mu of the third, etc., until you're done. Any questions on that? This would get very long with states in America. All right, now we need an H1. So this gets interesting. So H naught is that they're all the same, right? What do you think H1 is going to be? What does it mean for H naught to be false? Okay, and Jacqueline, you're asking, do you want the entire written just as you're showing? The answer is yes, but I wouldn't give you a question with, states in America. That would take all day long. So I would give you something that's more reasonable. Okay, so Ross suggests not equal sign. It turns out that doesn't work. If we just take all the equals and make them not equal to, that actually doesn't work. And here's the reason. What if we're in the case, and I don't know if we are, but what if we're in the case that the whites and the blacks are the same, the Hispanics and the others were the same distance from the library in population mean, but those pairs were different from each other? Then we'd have two equals and a not equal to in the middle. Do you see that? Does that make sense, Ross? Yes, you can't just turn all the equals into a not equal to, because that's not, turning the equals into a not equal to is not equivalent to saying that H naught's false. And it turns out there are some ways to do it symbolically. What I've learned is that if I try and tell you, no one really understands, so I'm not going to. So my strong recommendation is to do it in words. So we're going to go H1. That's the alternative hypothesis. And now in words, we can now, it's much easier to say what it means for H naught to be false. So all it takes to show H naught is false is two of them to be different from each other. If any two of them are different, then H naught is false. Is that clear? Do you agree? Even if the rest are the same, three of them might be the same, but then that fourth might be different. So in words, at least two of the population means differ from each other. Okay, and maybe even population mean distances from the library or the nearest library. Differ by race. Okay, and what I've found is that's much easier to understand when you read it than if you try to do this symbolically. There are ways of doing it symbolically. You got to use I's and J's and all kinds of weird stuff. I'm not doing it. Okay, I found that I think most people who read this sentence can look at it and say that's what it means for them to not all be the same. At least two of them differ from each other. Do you agree? Okay, so this is new in that for H naught, we use symbols, and for H1, we use words. Notice in the last chapter, we use symbols for both. For this class, we only use differ. That's a really good question, Ross. And the answer is, when you're doing ANOVA, it's not just this class, actually. That's universal, period. ANOVA is about differing. Yeah, so ANOVA never talks about one being bigger than another. Is there a test to talk about one being bigger than another when you have many? And the answer is yes. It's called the Tukey test. And we're not doing it in this class. Again, there's lots of tests. I could go all day long telling you more. Okay. Yeah, what I said, Jackie, is that don't even try to understand why the variance is there. Why that has to do with the mathematics behind the crunching out the numbers, and there's a variance going on, and the full mathematics that happens deep in your calculator that you'll never see. Are you okay with that? Okay, again, if you want to learn it, you need to take a math-based upper division or graduate level statistics class. Okay, and I've done that, so I know what it is. But unless you're a math major, you won't be interested, I promise. Okay, so right now, just ANOVA, you don't have to worry about the V. All right, any questions at all on the H0 and H1? All right, so the next step, as you're used to, is to go to our calculators. So the good news is all our calculators, okay, if you have any of the TIs, TI-84s, TI-83s, TI Inspires, they all can do ANOVA. Again, only good as a fit is the one that some calculators don't have, okay, of the statistics calculators. So I'm going to share my calculator, and I'm going to show you how to do this. It turns out it's really easy. You got to type in all the numbers, so there's a lot of numbers to type in. I gave you one that doesn't have too many. So now let's go and do a new share. And let's go to the calculator. And let's clear what we had last time. So what we're doing with the calculator is the first thing we're doing is what you're used to. We're going to go stat. We're going to go to edit. All right, well now we're doing ANOVA, and if you remember, we had the whites, blacks, Hispanics, and others. So we're going to have 4 different columns to put in numbers. So I need to clear out L1, and never hit delete, only clear. So clear, enter, and then L2, clear, enter, and then I got to clear L3, and then I'm going to clear L4. Now I'm going to just put my numbers in. So if you remember, L1 was 15, and then was 4, and now 11, and then 9, 3, and 2. And then we had L2 were the blacks, so that's 12, 1, 6, and 6. And then we had L3 were Hispanics, 9, 17, 5. And then 14, 7, 1. And then we had L4 will be the others, 18, 11, 2, and 8. And by the way, I do not have like some super memory. I should tell you, I should like confess to what I always do. I have 2 screens. I keep one screen with all the data in it so I could just look at it. So you're not supposed to memorize it all either. Oh, did I miss something? Oh yeah, it happens. I'm typing it in the computer, but it doesn't always, the keyboard doesn't always work well. Yep, that first one should be a 12. Let me look to see if I missed any others. 15, 4, 11, 9, 3, 2, 12, 1, 6, 6, 9, 17, 5, 14, 7, 1, 18, 11, 2, 8. Good. Okay, any questions on this so far? Okay, so now what I need to do is I need to do a hypothesis test. And you're used to this. I'm going to go to stat again. I'm going to go to tests. Now, remember, this is our last webinar and last chapter and last hypothesis test of the entire course. So because of that, it's the last item. So if I go up arrow, that'll go to the bottom. And you'll see ANOVA. This is actually very different than the rest of the tests in terms of what the Texas people did. I think they got tired. There's so many tests. And they just didn't want to do much programming. So if I hit enter, it doesn't give me any kind of menu or anything. It just says ANOVA. So now what I do is I type in second 1. I need to tell it what my columns are. Because remember, there were lots of columns in here. And then I go comma, and then second 2, and then comma, and then second 3, and then comma, and then second 4. And then I end the parentheses. Any questions so far? Okay, now that I do that, I hit enter. And there it is. So again, there's not much to do here. Okay, one thing, notice the very first thing It's something we haven't seen before, and it's important. Okay, hopefully it's not your grade. It is the F distribution. So we have seen a lot of different distributions in this class, right? We have seen the binomial distribution, the normal distribution, the t distribution, the chi-square distribution, and now this is the last distribution to work with, and this is called the F distribution. Again, the mathematics behind it is brutal, so I'm not going there. All I want you to know is that if I ask you for the test statistic, you write F equals, in this case, 0.3339. Got it? There is a graph. It doesn't look that much different than normal distribution, and then you could shade in and all that kind of stuff. I'm not going to get into the details, but let you know it's the same as all the rest of them. The next line, that's the important one. Okay, and that one we've seen that letter a lot. What does that tell us? It says P equals about 0.8. So what does that tell us? Again, you've had lots of hypothesis tests by now, so you should know what that means. Yeah, that's the p-value. 0.8 is bigger than any level of significance you'll ever use in your life. So it is statistically insignificant or not statistically significant. And now we're ready. Any questions at all on using the calculator? Okay, so now I'm going to go back to the question. We have some things to do. Okay, again, all the questions are basically the same with ANOVA. I'm only giving one example. So now we can say, hopefully you all know, there is statistically insignificant. There's evidence to make a conclusion. Whether or not. And I'm going to write it in the way that you often see in research. What we could say is race is a factor in distance from the library. Closest library, I guess. Any questions on that? Okay, if you want, you could also say there's statistically insignificant evidence to make a conclusion that whether or not at least two of the population mean distances from the library, nearest public library differ by race. You just repeat your H1. That's the same thing. But I wanted to give you the race as a factor because you'll see that sometimes in literature. I want to mention some things that we did that even if we rejected, by the way, then you would just state that race as a factor or you just state H1. Let me tell you what you can't do. ANOVA does not tell you which one's different. Okay, again, we know that at least two are different if you have a small p-value, or at least you have evidence for it. But it doesn't tell you which is the culprit. So all it does is say, yeah, there's a difference. Race is a factor, but it doesn't tell you which race was the one that was bigger or smaller. Does that make sense? In terms of population mean. If you want to be able to, okay, it's insignificant, the p-value. Yeah, Charles, so it's insignificant because of the p-value. If you have a p-value that is 0.8, which is what we had, that's insignificant. Notice I didn't even bother with the level of significance. At this level of sophistication, when people do ANOVA, they don't need a level of significance. They look at the p-value and then just say, hey, this is very clear. We had 0.8. Or if you had, say, 0.3, it's still very clear. If you had 0.03, then you have statistically significant evidence. If you had, say, 0.06, you only have weak evidence. If you had 0.001, then you have strong evidence. So remember, we talked about that. So in the real world, you're not given a level of significance. You just look at the p-value and then talk from there, right up from there. Okay, so, and often you use 0.05, but not always. Any questions at all about this so far? All right, repeat what you said before that. ANOVA only tells you. It only tells you whether race is a factor. It does not tell you, like let's suppose that we got a p-value of 0.01. It doesn't tell you which race is different from the rest. Do you see that? Yeah, it doesn't tell you which one. It only tells you that, hey, race matters. But it doesn't give any detailed information. Okay, the last thing I want to talk about with ANOVA, with this example or all examples, is what are the assumptions you need in order to run ANOVA? Okay, and some of them are the same as we've always had. I want to list those out. I think I need smaller font, actually. There we go. Okay, good. One is no sample bias. Another way of saying that is simple random sampling. Okay, and simple random sampling doesn't have to be exactly simple random sampling, but it could be approximately simple random sampling. You could do that with a detailed stratified sampling. I want to let you know on your first project, if you did stratified sampling, you only did it with one stratification. For good research, you need to stratify based on all the different things you're worried about maybe causing bias. Okay, I only had you do one so you could learn about stratified sampling. But again, in true research, you need to make sure that all the different worries about bias aren't there. Okay, so that's definitely one. There's no bias, which simple random sampling is a guarantee of it, or approximately simple random sampling. And that can be done in many different ways. What's another one that we've seen before? Yeah, use skewed distribution. That's actually the opposite. We don't want it to be skewed. And in particular, what do we want it to be? The distribution. Yeah, normal. And so number two is the sampling distribution is normal for each. So in this case, notice our sample sizes are really bad. They're all under 30, right? Or under 31. Okay, and even if you go to 20, some people go to 20, no chance. Okay, so here it's a major assumption, which is probably wrong. Does that make sense? So Ross says, why do we have the F distribution here? So if you want to learn, Ross, I think you've heard me say this before, you need to take a mathematics upper division or graduate level statistics class. And then you'll believe, in fact, you don't know what the F distribution really is. Okay, there's a very complex mathematical formula for it. I'm not going there. It's related to the normal curve, but it's not the normal curve. It's related to the gamma function, which you don't know what it is probably. Yeah, accept it. It sounds good. Unless you decide you want to be a mathematics major. And then don't accept it. Then take more courses. Yeah, just pretend it's good. Smile. Say, yeah, good. I trust the calculator. They're doing the right thing. Got it? Okay. Okay. Or become a math major. You know, like I said, I took courses in it. But you don't need to know it. Even if you get a PhD in psychology and you have to do all kinds of statistics, you won't learn why you use the F distribution or what it is. Okay. There's more besides this, by the way. We have SRS. We have sampling distribution is normal for each. We have some more. We need to make sure that the categories are independent. Okay, so it's not just asking the same person 4 questions, because that's dependent. If it's dependent, as I've told you before, there's going to be a test for it, but we don't learn it in elementary statistics. So again, there's a lot of different things you can do. Okay, and I'm not going to get into it, but there's more. Again, there's a lot of things that you have to do, and this is why I told you you're not going to understand the depth of this test. But I just want you to kind of see these. Another one is the standard deviations, the population standard deviations, all right, SD for standard deviations, are all the same or close if the sample sizes are close. Okay, there's another one where, good luck. How are you going to know whether the standard deviations of the distance from the library that different races live are all close to the same? I have no idea. So, big assumption. Okay, very hard to find out. It turns out, Jacqueline, more than 2 groups, you can actually do ANOVA on 2 groups, but there's no need to. When you're looking at the F distribution, and this is where you just trust me, the F distribution is different depending on how many groups you have. And it turns out, if you have 2 groups exactly, it becomes normal. And then it's just, or a T, and then it's just a T-test. But that's why there's no reason to do ANOVA with 2 groups, because you can do the test for the difference between 2 population means much easier. Does that make sense? Yeah. And except you do have to have the sample standard deviations the same. So you can't always do ANOVA with 2 because you got that sample standard deviation issue. Okay, I don't know if you remember there was that pooled thing that I always said just say no to. If you say yes, then it's the same as ANOVA with 2. So just trust me. Sound good? Okay, there's all kinds of details I don't want to get into, and you don't want me to. Okay, so again, simple random sampling. You need to make sure the sampling distribution is normal for each. Categories are independent. Population standard deviations are the same or close. One more that's actually not that hard, but it's important, and it can happen, it could be an issue with ANOVA, is the data collection was the same. For each category. The reason why this could be a problem is, let's suppose you wanted to do the kind of state and the height thing. The problem is there's no way you can conduct a survey in all 50 states by yourself, because it would take forever. Do you agree? You'd have to travel to all the different states. So what you would do is you would hire a team of people to all do it. And you want to make sure that you meet, maybe online, that's fine, to talk about how you're going to collect the data and make sure that person in Minnesota is collecting it in the same way that the person in New Hampshire and all the different states. So again, with ANOVA, that can become complex. You're talking about many groups, and sometimes you're going to have a big team collecting the data. Okay, but in this example, it's probably one person doing it, so it's no big deal. So that's pretty much it for what we're doing from chapter 13. Are there any questions at all about ANOVA? Any questions? Okay, this is actually the very last topic in the entire course. There is no more statistics to talk about in this class. The one thing I do want to do, and this is a good time to do it, because my guess is no one's going to leave right now. Would you recognize memorizing the assumptions? Yeah, probably a good idea. I could ask you. You can either memorize them or write real small on your note card if you want to do that. So that's your choice. You should know the assumptions for all the different tests, right? You know, for a t-test, you have to make sure that each of the distributions are normal. That's the main thing. SRS is always one of them. You know, for a regression analysis test, you have to make sure that for every value of X, you have an approximate normal distribution in Y. There's all kinds of different assumptions for each of them. For a test for proportions or chi-squared. You have to make sure that your hypothesized counts are all bigger than 5, okay, and NP and NQ, both of them. So there's different, you should know all of the different assumptions, okay, that you're making. Assumption may not be the best word for it. Requirements is probably a better word, because sometimes you don't have to assume. If you have sample sizes bigger than 30, you don't have to assume it's normal. You have that it's normal. Do you see the difference? So it's a requirement more than an assumption. All right, so the last thing I need to do, since we're finished with the regular lecturing of the entire quarter, is, let me do this, there we go. Is give you a secret word. And this is the very last secret word. And Ross almost got it already. Nope. The secret word is? It's 2 words, actually. Thank you. Because again, especially you, all of you are here. You've been coming, which is good, and I want to thank you for being patient. I know this is a hard class with lots of frustrations. I do my best, but I can't be perfect. Hopefully, you'll do your best and study really hard for the final. So the secret word for this week, and it's the very last secret word of the entire quarter, is thank you. Okay. And by the way, I want to note, none of you are in this situation, but there are a couple people still in the class that have missed a secret word. And remember, if you miss a secret word, you got to write a 5-page paper. You got to watch that webinar and take 5 pages of notes. You remember that? So I looked, and at least you guys are fine. But there's a couple others that are not fine. And that has to happen, or it's a 5% penalty on the course grade per missed secret word. So that's just a note. So let me talk about, now that we're done with this completely, let's talk about the final exam. So let me go to Canvas. And let me find it. There we go. Okay. So here's the thing. Let me go back to the syllabus. I think first might be best. And remind you about my exam policy. You get a single 3x5 note card. You can write in front and back. In the instructions that I will give to your proctor, it will say you get a 3x5 note card written front and back. Okay. Definitely bring your calculator. Pretty much, if you do not bring your calculator to the final exam, you'll be retaking this class because you won't be able to do any of it. It'll be horrible. You'll be crying. So I recommend bringing your calculator and also bringing spare batteries as a just in case, because you never know when batteries will die. So that's a big deal. The final exam is 30% of your grade. That's a big deal. Okay, you can't pass this class if you don't take the final exam. And the calculator, most of the final exam needs a calculator, and you're used to that at this point where everything we've been doing has to have a calculator. You can't get to the p-value, okay, or the confidence interval, okay, or regression tests or whatever you're doing. So that's a big note, is that you must have the calculator, and the 3x5 note card, totally up to you on what you want to put on it. Okay, there's not that much space, so do your best. Memorize what you have to, but don't memorize what you don't need to, is my recommendation. Okay, everything is exactly the same in terms of rules as a midterm. So I'm not going to read through this again, but just quickly, you get 2 hours, you have to have a proctor. the Wednesday before, which is in 2 days. You have to have sent me your midterm information so that I know who to send it to. Absolutely important. You cannot take the final exam late, period. Okay, so make sure that you can make it to the final exam. It's over. When after you finish taking your final exam, the course is over, just to let you know. So don't email me asking for extra credit. That's not going to happen. Don't email saying, what can I do now? The answer is nothing. So it's over when the final exam is over. Okay, and I don't give extra credit anyway, but between now and the final, you can do a lot of studying. That's what you can do. So you must take the final, and it's a big part of your grade, so you need to do well in it. So I want to go to the modules where we have our final exam information. And also I'm watching the chat. I'm listening too. So if you have any questions, please ask them. I'm trying to make it so that you know what you're coming into. All right, so the first thing is, just like the midterm, I wrote the final exam and then erased a bunch of stuff. And then I posted that. So Charles has a question: the final overall grade in the class is posted on Canvas or somewhere else? The answer is somewhere else. It'll be posted on Canvas, but I think it may not matter because, again, once the course is over, I don't think you're able to get into Canvas. And that's not because of me, that's a college policy thing. So you may not be able to see your final exam on Canvas because you can't get into Canvas. It'll be there, but I think you may not have access anymore. So you can get your final exam by going to your transcripts, your final grade. Okay, so you'll go to your transcripts, and that will be your final grade in the class. Does that make sense, Charles? Okay, the bad news is, although I think you all know I'm not a procrastinator, hopefully you figured that out by now. So I'll have everything done. In fact, I'm going backpacking right soon after. So I'm out of here because I like to play after I'm done working. I don't know about you guys. So the final grade, you'll probably be able to see on the exam, because my guess is I think the class closes Thursday, and I should have it there by Thursday, but you better check like right then. Does that make sense? If you wait too long to check, you won't be able to see it because the class will be closed. So sorry about that. I can't do anything about it. I post on Canvas, but then Canvas disappears for you. Okay, so you got to keep checking. I think you get a notification when grades change. So watch that. Watch your email, and it'll show you when the final exam's graded. Okay, and make sure you're checking your college email, LTCC email. Okay, so let me get back to, I wrote down a final structure. And again, I don't know how easy it is for you to see because it's pretty small font right now. But when you open it yourself, you'll be able to see it. So I want to note a few things. This is important. Problem number 1 is the most important problem on the test. No question about it. You can't do number 1, the entire final will go bad for you. And that is match the following hypotheses and estimates with the appropriate test statistic or confidence interval. And guessing is probably not going to be good for you because there are 15 different confidence intervals and hypothesis tests we have done. So you need to make sure that you can recognize which confidence interval type or which hypothesis test is the proper one. Okay, although this is just problem number 1, many of the other problems, basically, that's the first thing you have to do to succeed in it. Because if you use the wrong test, it's just going to go badly for you. If you do ANOVA when it was just a test for a single proportion or something, you're going to be so stuck. When you say what you mean here, you mean what does this look like? I'll show you that in a bit. I have more than an example. I have an app. Yeah, so I'll show you the app. Okay. Problem number 2. Circle either true or false. And then I have an app for also. And there's an A through J. I think that one I had you go to for the midterm. Now you can go for the final also. And I have an app for that. Okay, problem number 3. Notice it says paragraph. Your final exam is not going to have the word paragraph. So what does that mean? So what does it mean that it says paragraph? Okay. Do it. I'm not sure what that means. It's not going to say do it either. It's going to have a paragraph of information. So it's going to have a paragraph of information about some study that was done with whatever information that you need to be able to conduct a hypothesis test. So when I say paragraph, that's what I mean by that. Then it says state the null and alternative hypotheses, find the test statistic and p-value, state your conclusion in the context of the study. On part C, what are the first few words to the answer of part C? Everyone has exactly the same first few words. To the answer, not the question, but the answer. Yeah. Stat, sig, and actually the first couple words is there is. That'll get you started, okay? That'll get you started. It'll keep you from making the mistakes other people make, which is other first few words. And then it's going to either be statistically significant or statistically insignificant evidence. But there is will get you started. So be ready for that. Practice, okay? I will be very disappointed if I don't see the 2 words there is on problem C. But I know a lot of people don't study. So if you study, you'll practice and you'll do these there is. Okay? Then use a complete sentence to interpret the p-value in the context of the study. What's the first word on interpreting the p-value? First one word. Yeah, if. Okay, again, the thing is, you guys, you're probably the ones that know how to do this stuff. I'm worried about the ones that don't show up to the webinars. Okay, so if, and it's like, if another study was done with however many, whatever that you did, et cetera, et cetera, et cetera. It's a long one. Part D is a long one. Just to let you know, the one thing that's very different about this compared to the real final is I give you a lot of space on the real final. Okay, you can be writing a lot, so I have to give you a lot of space. Okay, and then E is why is it appropriate to use a normal distribution for the hypothesis test? So that's where there's basically a couple types. One is you got to make sure the sample size is greater than 30, and the other is you got to make sure that you have greater than 5 for the expecteds. When to use which? Do you remember? So one of them is you got to make sure that the sample size is greater than 30. And the other is you have to make sure that the expecteds are greater than 5. How do you know which you have to do? Yeah, proportions versus mean. So look at the survey question. Think about the data that you would put in the spreadsheet. And if the data are a bunch of numbers, then you're talking about greater than 30. If the data are a bunch of words or a bunch of yeses and nos, then you're talking about NP and NQ greater than 5, or the expected is greater than 5. Is that clear? Okay, don't make the mistake of switching those. The reason I'm kind of emphasizing all this is I've been teaching this, I don't know if you know, for 25 years, longer than some of you have been alive. And I'm so tired of seeing that mistake. But it doesn't matter how much I say it, I'll still see it. So hopefully you'll pay attention. Those who pay attention won't make a mistake. It's not a trick question. Okay, problem number 5. For each part, write down the sampling distribution, sketch the chart, answer the question, and determine if the normality assumption was necessary. And there's an A through C. When have you seen this before? Yeah, on the midterm. This is exactly the same type of question as the midterm. So, what should you do for studying? What should the first thing you should do for studying be? Practice, actually before practice. Jacqueline, practice is the second thing you should do. Review, but what should you review? Discussion, no. Yeah, the midterm key. I posted the key to the midterm in the week 8 module. Okay, so I posted that key. Look at that key and you'll see what I'm expecting. Got it? I give you the format. I want to see that format. Still a question on problem 3E. If the hypothesis test of the population mean, if the sample size is greater than 30, you can write it's not appropriate to use it. No, it's actually the exact opposite, Ross. Is that if the sample size is greater than 30, it is appropriate to use the normal distribution because you have it. You could say it's not necessary to assume it's normal, but it's appropriate to use the normal distribution because you don't need to make the assumption because of the essential limit theorem. Does that make sense, Ross? Yeah. Assumption and appropriate are very different words. It's appropriate means that you're in great shape. Assumption means you're screwed. See the difference? Okay, so problem number 4 again. The first step is to go back to that midterm key, look at it, look at the expectations I have, look what an answer looks like, and then practice. I'm going to give you another hint also. There's an A, B, and a C. On the midterm, you only had A and B. Why do you think I'm giving you 3 this time? What are the 3 types? Do you remember? You remember? I know it's been a little while. It's been like a month or and a half or so. I think we did that in April. Okay. Not uniform normal. Not uniform normal. Uniform normal, it's all normal with sampling distribution, right? Either you assume it's normal or you get that it's normal from the essential limit theorem. Okay. There was a single element. Okay. There was a mean, and then there was a total or a sum. So there were 3 types. So what you need to do is practice all 3 types. And I'm not going to tell you which order I'm going to give it to you. I'm going to tell you all 3 are there. I'm not going to tell you what order though. So I want to tell you which is A, which is B, and which is C. And in one of them, there's going to be an norm. I'm not going to tell you which one either. Just let you know that. Any questions on that? Okay, number 5, I made kind of ambiguous. And that is a question from chapter 3, 4, and 5, and a question from chapter 11. Okay, there's multiple parts on this one. And I'm not going to give it away, so you can think about it. So there's definitely going to be a chapter 11 one, that's a guarantee, and then one of these guys also. Problem 6, confidence interval question. So again, you should know how to find a confidence interval using your calculator. You should be able to make a conclusion. You should be able to talk about the confidence level, and you should be able to understand whether you had a large enough sample size. Okay, number 7. So number 7 is a little bit like number 3, except they ask slightly different questions. You got to state the null alternative hypothesis, state your conclusion, and then interpret the level of significance. Any questions on that? We did a lot of hypothesis testing, so you're going to see a lot of hypothesis testing. Okay, problem 8. It's a question from 2, 3, or 4. Okay. Okay, and maybe I should say 2, 3, and or 4. Could be more than one at the same time. Problem number 9. Problem number 9 is a chapter 12 question. So it's a regression analysis question. I'm going to ask you to find the equation of the regression line using your calculator. You need to use it to make a prediction. Then I'm going to ask you to interpret the slope and y-intercept, if relevant, in the context of the problem, or state why there is no relevance. Okay, context of the problem means that don't just give me the definition of the slope or the definition of the y-intercept. It needs to be in the context of the study itself. Okay, and then question C is use a complete sentence in the context of the study to interpret R squared. And then D, use a level of significance of 0.05 to determine if the regression line is useful. Okay, and then plus more. I'm not going to tell you what the more is. All right, what's the best way to study this one? Yeah, the discussion board. Okay, definitely look at my model. Definitely look at my model. Not everyone else's was correct. Look at my model. Okay, you can look at others and you can critique them. Some were correct, some were not. But my model should be correct because that's the whole point. And look at my model and you should be able to write that stuff out. Any questions on that? Okay, question 10. Question 10 is another hypothesis. And I think I'll even give you a hint on this. It's either going to be chapter 11 or chapter 13. Again, we did a little chapter 13. We did a lot of chapter 11. Spent a whole week on chapter 11. But there's also chapter 11 earlier, so it's a 50-50. I will tell you, I had a problem 10 and problem 11. One of them was chapter 11, and one of them was chapter 13. And I looked at it, the test, and I decided it was too long, so I got rid of one of them. I'm not going to tell you which got rid of. So I apologize if your favorite test is not there. Because if I gave you every detail of this class, there's no way you could finish it in the time you have allotted. All right, so that is, again, the final exam structure. I recommend you practice each type of problem until you start getting them right every time. There's no extra credit on this one. That's just for the midterm. Okay, so again, I recommend that I'll show you some study tools. So let me go back. And I put it into Review Applets. If you click on Review Applets, and then you click the Review Applet, so it opens up a new tab. And you will see Practice Classifying Statistics Problems. New means I had to change it. I originally wrote these in Java, and then Java doesn't work anymore because our college doesn't have security stuff, and I had to rewrite the whole thing. So now it's in JavaScript, which means it should work on everybody's phone. It should work on your computer. It should just always work. That's the good thing about JavaScript. In fact, what I did not realize is that this particular app is used all over the country, like in every state in America. I didn't even know that was true until it went down one day because we had an electrical outage. And I got emails from, like hundreds of emails from people saying, what happened? So this is the app that like every statistics class uses, especially AP stats in high school. I was surprised. So here's the thing. It gives you a bunch of choices for categories you want to work on. What categories do you think you should try working on? All of them, exactly. By the way, for the AP exam, which you're not taking, there's some of these that are not on the AP exam. I kind of learned that when I heard from all these people when it went down. So I'm going to go select all. And then I'm going to hit submit. Let's do one. Okay. By the way, if you're from Tahoe, you know that this is very relevant for us. The bears that raid trash cans in the Tahoe Basin have a higher rate of survival over a 1-year period than bears that do not raid trash cans. Okay, 34 bears that raided trash cans and 34 that did not raid trash cans were observed. So what you have to do is decide, choose the confidence interval hypothesis test that will help you with the above research. Okay, let's see if you can tell me which it is. See if you can type in the chat box what you think, or just tell me. That's fine too. You can always talk. There's a lot of choices here, so guessing, a complete guess is unlikely to get right. At this point, you should know how to, if there were, there were 10 of these, you should be able to tell me the probability of getting them all right with 10, which is basically almost 0 if you just totally guess. So what do you think the answer is to this one? Again, either say it or put it in the chat box, and then I'll pick the one you say. It's okay if you're wrong. This isn't the final. You don't want to be wrong next week or when you take the final. Hypothesis test, difference between two population means. So should we try it? Okay. Definitely has to do with proportions. Okay, Ross says something different. Let's see if a third person can say which it is. Is it 2 proportions or 2 means? Bailey, Jackie, Zach, Charles, Justine. Any ideas? I'm looking for a tiebreaker. Any thoughts? Okay, 2 means. So let's go for 2 means. Okay, hypothesis test for the difference in 2 means, independent samples. Okay. So notice the variables are not quantitative. Okay. What are you going to ask that bear watcher about the bear that just raided your trash can? You're going to ask, hey, did you live? Right? Did that bear live? Does that make sense? Yeah, live or die. Okay? It's not a number. A bear lives or it dies. That's all it does. That's how survival is, right? So notice you always want to read what it says. The variables are not quantitative. We have a yes or no question. Please try again. So I tried to give you hints. There's a little AI built in to this system. And I don't know if you call it AI. It's machine learning might be the right thing. So that it will help you in guiding you to the right path, but not give you the exact answer. So, so what do you think it is? Let's do a hypothesis test between 2 proportions. And that smiley is what you want to see, by the way. So that was correct. Okay. Can you play? Okay, prediction for a single value of y for a fixed x. Yeah, that's regression analysis. Because that's the whole point of regression. Is you have 2 variables and you're given an x and you try and guess what the y is, right? Does that make sense? Yeah, it was hard for me to kind of like, what word should I use on that? But that's really what you're doing, so that's why I use that. Okay. I'm not going to do this all day, but how many of these should you do? Okay. Oh, I don't think you're going to have time, Jacqueline, to do them all. There's several hundred, by the way. But what I recommend is you keep doing them until you get them right consistently. Does that make sense? And then you'll start understanding how to figure out what test to use. So that's what I recommend. And everyone's going to have a different number that they need to try, because some of you are right there that you pretty much got it. Some of that you need some extra help, and some of you need a lot of help. And so keep going until you're starting to get them right pretty consistently. Okay, so let me go to the next review applet. Same link. And this is the one I already showed you, and that's the true-false one. So which should I click for the true-falses for studying for the final? Yeah, all of them. So select all, hit submit, and let's do one. Okay, a researcher hypothesizes that the average student spends less than 20% of their total study time reading the textbook. The appropriate hypothesis test is a left-tailed test for a population mean. True or false? Okay, so Charles says false. Let's try that. Okay, that little sad face is not what you want to see, by the way. So it's true. It's left-tailed because we're checking to see if the average is less than 20%. Less than is left side, right? Okay, this is a mean and not a proportion. So it's a mean because the survey question is how much time, right? How much time did you spend reading or what percentage of time did you spend reading your textbook? And you might say, oh, I spent 10% of my study time reading the textbook. You can answer with a number, 10%. Do you see? Okay. Any questions on this example? Okay, same idea. You should do these until you're getting them right. All right, next, I want to show you. I want to show you this guy right here. I actually posted this about 5 minutes before I logged into this webinar. It says, I was worried about this, about posting it. I don't want you to be afraid. Okay, this is a large collection of past questions. These are actual test questions that I have given in the past 25 years. Okay, I think I created this about 4 years ago or so. So this is like 20 years of questions. And you will see it's still going, still going, still going. It's loading and loading and loading. There's 195 pages of test questions. So if you want to practice questions, this gives you a near unlimited amount of questions to practice. If you click this guy, then I have an outline for you to practice that I created. This is actually a Google Sheet that I made. And I decided, this might be a good, useful resource. Okay, sometimes I take questions directly from this. And don't even think about studying, all whatever 195 pages and trying to memorize the answers of 195 pages of questions. But these give you as many questions as you can possibly basically practice. Do you agree? So a lot of people say, well, do we have practice questions? Past homework could help you. Everybody has a different learning style. If you're going to do past homework, make sure you write out your answers. So when I give you a multiple choice on the conclusion, write it out. Don't just click on the answer. Write down the full sentence, because you need to practice writing out full sentences. Just like the midterm, there's a lot of writing. So doing past homework is only okay if you're going to write it out. I do not have a key to this 195 pages. Sorry, Ross. There's no way I will ever have that much time to do this. Okay, I copied and pasted all my questions, is what I did. And I would have to write out the keys, and I can't do that. Sorry about that. Okay, that would take me, an eternity. Okay, so that's a nice That's a nice study practice sheet, basically. You know, don't do them all because it's too much, but do them until you get good at each type. Okay, almost there. Let's see what else we have. I did create a practice final. I created this a long time ago, so again, this is a bit older than, say, the other questions, some of the other questions. Some are older, some are newer for the other ones. So this is a practice final. This does have a key. I don't recommend looking at the key until you try every problem. Okay, don't try one at a time. That's what the homework is for. Do past homeworks to do one at a time, but to do a practice final, sit down, try the whole thing, see how you do. Okay, this does not go through as my specific outline goes. It's not that order or anything. I wrote this a while back. It is 10 problems though, coincidentally. Okay, so those are some resources. Again, there's a lot of resources. It's up to you for studying for this thing. This is a high stakes test. You have to do okay on it. Some of you, it's much higher stakes than others in terms of where you stand in the class right now. You know, if your goal is to pass, if you got an A right now, then you're fine. Okay, I mean, you have to take the final, but if you're sitting there at 69%, this is like all or nothing. You have to pass this final to pass the class. This is it. This is our last meeting, Jacqueline. Okay, this is our last meeting. I'm not done helping you, but this is our last webinar. I do one a week, and some people are taking the final this Friday. So it'd be silly for me to make people watch a webinar after you've already taken the final. Once you've taken the final, your class is over. So this is the day, and yeah, and there was a request to have it on Monday. I was going to have it on Tuesday, and you wanted on the Q&A forum. There was a request for Monday instead. So that's why it's pretty far before, because you guys wanted it. So again, there's not too much outside the final study to do. This chapter 13 is the shortest of all the chapters in terms of the homework. You will find the discussion assignment to be the easiest discussion assignment of the entire quarter. It's just to be nice to each other discussion assignment, basically. So please don't do it late. If you get less than 10 out of 10 on the discussion assignment, you're just not getting it. Okay, it means that you're just not opening it up on Thursday. Does that make sense? And yeah, if you do it after Thursday, you don't get 10 out of 10. But there's nothing to do. There's no wrong answer. The wrong answer is leaving it blank and not posting. That's your wrong answer, Charles. If you don't post, you get the wrong answer. Okay, or if you don't answer, if you don't reply, and you need to reply and answer, you know, do what it says. But again, there is no excuse for getting anything other than a 10 out of 10. You're ready to do it anytime. You could have done it on the first day class. Well, maybe not first day class, but you could have done it last week. Okay, so again, there's very little to do this week in terms of new material. There's just chapter 13. It's not that hard. So you need to focus all of your effort in studying for and practicing for this final exam. The final exam is the high stakes piece of the course. Okay, just to give you an idea, we can see this on the syllabus. So the final exam is worth more than all of the homework assignments and all of the discussion assignments combined. This is why you got to take it really seriously. Okay, the homework assignments and discussion assignments are what I call formative questions. Formative tests, which means it's low stakes. Whereas the final exam is called a summative assessment, which means high stakes. Okay, and that's how finals should be. In the university, that's how it is. Finals are always high stakes. So again, I can't underemphasize how strongly this is. This is really important. So I will be checking the Q&A forum. And really, that's the only, and this week's discussion forum, which is easy. I'll be checking the Q&A forum pretty often. I don't have any like big long day plans from now till next Wednesday. Okay. But after that, by the way, if you send me an email, I may not get back to you for a while after the final, after I grade the final, because I'm backpacking. When I backpack, I'm off the grid. You can't find me. You can't get a hold of me. If you've ever backpacked, you know what I'm talking about. That's what I like to, that's my fun. So before the final exam, I'm going to be watching the Q&A forum often. Okay, so that's a good question, and that just has to do with how you read it. Actually, I can't. Oh, actually, I can. I got to launch student view. I don't want you to see everyone else's grades. There we go. So if you go to the grades, this is student view. And yes, the final exam is 100 points. That just makes it easier. So you see the final exam is worth 100 points, but the final exam in terms of percentage of the course, oh, this is weird. Oh, because I haven't done anything yet. The final exam in terms of percentage of the course is set to be 30%. So I make it 100 so that you can easily read it and know what that means as a percent. Does that make sense? So it's 100 points so you can see what the percent is. The what if should work, actually, but you want to do it out of 100. I've never tried it with the final, but and I'm not even sure with how as an instructor I can. Students have to do it. Yeah, the what if should work because I do have it set for 30% of the course grade. Okay. Other questions? Will this exam be graded on a curve? A slight curve, not a complete curve. I don't grade on, actually at this point in the class, you should all know what curve means. I don't plot a normal distribution curve and decide where you belong because I found that you usually don't get normal distribution. It's not even close in this class. There's kind of those who get it and those who don't get it. So it's not quite that kind of curve. But I do look to see if you got it or you don't got it. Okay. But since we're in a stats class, I can actually talk about the normal distribution curve, and that's not what I use. Okay, but it is 90, 80, 70, 60 when you see your score. So I'm done talking about the final exam, but I'm always happy to answer questions. Whatever you have. And what I recommend, if there's a problem that you're working on and you don't know how to do it when you're practicing for the final, copy, paste it, put it in the Q&A form and say, hey, how do you do this? I'm working on this. And I'll be happy to try, or even better, why don't you guys try to answer it? I'll look at it and see if you answered it right. And then everyone gets to practice. Always better. But I'll also answer it too. But if I'm teaching or sleeping or something and don't answer it before you see it, why don't you try answering it? If someone posts. Always a good idea. Okay, any questions? Any questions? Okay, and again, thank you all. Again, it's a tough class, I know. Don't shoot the messenger on this, but I have a certain amount of material I have to give, and hopefully I do my best is all I can do. Okay, hope none of you let me down in the final. I would love to see all of you get the final like really well done. That would make my year. All I do is write down your score. I don't give you a score. You give yourself a score, basically, by what you write on the final. I just read it. Okay, any other questions? Zach or Justine or Charles, any questions? Priya, any questions at all? Okay, again, if there's no questions, we can say goodnight. Okay, have a great semester or quarter, actually. Thank you all. I think it's... Yeah, for those who are in a different college, it's hard to get used to quarters. But anyway, thanks a lot. And I think I'll just kill the, where is it? Zach, any last questions before we end? We'll say goodnight. Or for you, it might be good day where you are, I'm not sure. Or good morning or something. Okay, well, have a good one, and thank you all for watching this. Don't forget to find the secret word and post it, and I wish you all a successful final exam.